Hi, I'm Larry Dignan with Constellation Insights, and we're here with Nate Melby. He's a BT150 member and CIO at Dairyland Power Cooperative. Hi Nate, thanks for joining us.
Thanks for having me.
So let's talk about utilities and the IT infrastructure that's unique to it.
Sure. Utilities are an interesting place to be these days because as an industry we're going through transformation. And the traditional infrastructure of IT certainly applies to the corporate side of utilities, but our operations technologies are where we're seeing massive transformation too. So not only are we transforming our information technology, but we're also transforming those operational technologies. We're in the middle of an energy transition, so we're seeing the sources of our generation change. And so as we add more renewables to the grid, it creates some complexity, it creates some new use cases and new scenarios that we have to manage. And so all of that becomes big when you try to do it at scale.
So what are the unique, IT issues in the field with renewables?
So one of the challenges is, the sun doesn't shine all the time and the wind doesn't blow all the time. And so when that happens, and our utilities in the upper Midwest, so we have extreme weather conditions. Winters are very cold. So how do we continue to sustain the right type of generation for the load that we have across our utility and make sure that we're resilient in the event of those extreme weather conditions?
And does that mean like Internet of Things, edge computing? What does that mean exactly?
Yeah, so Internet of Things comes into the future view. There's been a few concepts in our industry like the smart grid, the smart grid means for us, and then the evolution of that. But also trying to understand in real time the performance of our power grid and what that may become. So, in the old days you had a power plant that would run and you could control that, but it would run kind of at a steady state and be dispatched to run at a certain level. With renewables, you have changes in real time. A cloud goes over a solar array and the generation drops off for a certain period of time, or weather changes or things like that. And so we need to be able to control very quickly. It's not a 15-minute decision in the future. It may be real-time interaction. So we see opportunities for machine learning and artificial intelligence. Apply that to those problems and see if there's maybe some potential for us to automate some of that decision making to provide better control and more resilience.
What's the timeline for that?
I think it's coming faster than maybe as an industry we have been prepared for, just because of the demand and need. But I would say we're already starting to see the beginning of those types of concepts. We're seeing integration in ways that we haven't integrated on the power grid before. We even have a notion now that's beginning of a virtual power plant and what that could mean. So connecting different types of generation resources, but connecting them in a way that we can actually predict and scale up and scale down, or ramp up and ramp down the generation. Combining storage with the renewables so that we can capture that energy and use it when we want it instead of just when it happens.
So does that mean you're going to get to a point where you kind of have a digital twin of a grid?
Absolutely. And I see huge potential for digital twins in our industry. From everything from the traditional coal power plant, understanding what the maintenance would look like or the impacts of certain decisions toward maintenance in that huge generating machine. You'd be able to predict degraded performance better, and also so take that instance, multiply that by a fleet, and then take that and add the renewables and digital twins of the renewables, and you can essentially create a virtual model to predict your future performance.
So you mentioned machine learning and digital twins and things that are a little bit down the line. What do you have to do to your data infrastructure to get that? How do you set yourself off of that?
Yeah, it's a heavy lift. One of the advantages that I've learned in the utility space is that historical data and the capturing of historical data has always been something we've had to do. And so we have a really good foundational data set, data structure, but leveraging that for the future and what it becomes, it's really about data governance. So, how do we build the right architecture and the right structure so that we can leverage that and use it as a platform to project into the future for the future needs?
And then how far back do you go with the data?
Well, it depends on the system, but in some cases we're required by compliance to keep many years.
Okay. Yeah, I was just kind of wondering what time frame is more valuable. Is it the last 10 years? Is it 20 years?
Yeah, to your point. So let's just say that in a certain case we're required to keep 10 years of data. That's interesting historically, but the thing that will be different is 15-minute intervals or 5-minute intervals of data. historical is useful, but in the future, we're seeing an explosion of data points and an explosion of capture that industrial Internet of Things becomes reality, managing those interactions. So we're seeing exponential growth in data needs and exponential growth in the data that we have to store.
Right.
And so the platforms to manage all that will be a challenge.
So I guess what vendors is it a cloud play? Is it on-prem? Like how do you, I mean, you're obviously a very regulated industry, so it's a question of what you could even do, right?
Yeah, so the regulations and the compliance side is a huge consideration. Cybersecurity is also a very important consideration. And traditionally in this industry, with the level of control that we've needed, the cloud has not been something that's been in the nomenclature of the operations side. It has been on the corporate side.
Right.
But we're now starting to see in some of those areas like energy management systems where the cloud is coming to be part of that. And so they're starting to build the architectures, but they have to do it through that diligent, careful lens of how do we keep this secure and how do we continue to manage it within our compliance boundaries. But it starts with energy management systems, and then it extends into things like distributed energy resource management, and how do we integrate the operations between utilities across regions? How can we interoperate with all of that and effectively distribute and dispatch those resources?
What are some of the most valuable use cases for utilities? Like what gives you the most bang for your buck?
That's a very interesting question because I think utilities, it's really about efficiency. It's really about trying to find ways to create that efficiency and improve our business cases so that we can operate at lower costs and lower rates. And especially for the type of utility that we are, our mission is the lowest rates possible. So we make decisions based on that. But some of the use cases are things like, how do we predict what the future loads may look like or need to look like? How does the weather impact us, and can we more accurately predict that so that we can effectively manage our resources in that environment?
Sustainability, it's obviously intersects with efficiency and all. How much of that is a priority and where does technology fit in?
Yeah, sustainability is actually one of our largest goals. And I think it intersects with technology when we talk about that efficiency that we're trying to create, the information and data that we need to effectively manage the grid. But then there's also this other layer, which is sustainability of our utility for the people that need us. We provide power in rural areas. We were created to solve a quality of life issue where it couldn't be profitable to provide power in rural areas. And so our whole mission is to provide that power at the lowest cost possible, but also as efficiently as we can now and into the future. And the diverse resources that we use to generate that, the way that we transmit that, it's all been evolving as our industry's been changing. We're seeing this energy transition happen.
All right, thanks for joining us.
Thanks for having me.